Okay, this is the 2-4 notes for algebra. We're going to look at linear functions and their domain and range. So any equation, y equals 4x minus 1, can be rewritten using function notation. Function notation simply means the function of x equals, and then you have the rule. So function of x just means that x is the input and f of x is your output. It's just another way of naming our y-axis. So what it does is it allows us to see what are we plugging in for x. It basically tells us what we're plugging in for x. Or we can say, okay, now here's your function. Now plug -7 in where x is in that function and tell me what you get as an answer. So that's what we're going to do here. We have f of 5 where f of x is x plus 7. So 5 is being put into the function of f of x plus 7 every time we see an x. So every time I see an x, I'm going to replace it with a 5. And then I'm going to solve. So 5 plus 7 gives me 12. And that's it. So if I was writing this as an ordered pair, 5 would be my x and 12 would be my y, or my f of x. So again, it's x, f of x, which is the same thing as x comma y. So that's how you can remember what goes to what. So let's do another one. So we're going to put -3 into every place we see an x, including inside here. So g of -3 equals 3 times -3 minus 8. And now we simply use PEMDAS to finish out the finding out what the answer is, the solution is. So 3 times -3 is -9 minus 8 gives us -17. So that is what g of -3 is. Or another way to write it is -3, -17 as a point. Okay, so here we have x's in two places. Doesn't change anything. We're just going to put -4 in every place you have an x without changing anything else about that equation. The square stays the same, the minus stays the same, because that's part of the original rule, not the number -4. Then we take and use PEMDAS. So parentheses, exponents. So -4 squared is positive 16 minus -4. And then we're going to do the opposite of minus. Minus and a negative become a plus. And that gives us 20. So our answer is -4, 20. Okay, and I've already done this one because it was quite complicated. But as you see, 5 gets replaced into only the x box, but nothing else about the equation changed. The negative outside stayed, the square stayed, the 6 stayed, and then we treat it that way using PEMDAS. So parentheses, we didn't have any parentheses or things inside operations inside the parentheses, so we go to exponents. So we do 5 squared, which is 25. The negative stays on the outside because it was not in the parentheses. Then we do multiplication. 6 times 5 is 30. Then we do add, subtract from left to right. So -25 plus 30 is positive 5 minus 4 gives us 1. Okay, one more example. Let's do this one right here because it has the absolute value. G of -7 is absolute value of -7 minus -7 squared. Notice I put the -7 inside parentheses because we had a minus sign here. We have to keep that distinguished from these two distinguished from each other. So -7 minus -7 squared is 49, positive 49. And then we have absolute value of -7 minus 49, which is the same thing as adding those two. So that's -56. An absolute value makes that positive, so it's a positive 56. Okay. All right, so use the functions from the left. So they've given us some function rules, and they say use those functions to solve when you have a combination of a numbers times a function. So if you look at here, we have f of 4, where 4 is the number we're putting in for x in the f of x function, plus, and then we have to add 9 on top of that. So 4 replaces this x times 3, so 8 minus 3 times 4. But then we can't forget that it had a plus 9 at the end, so we have to add that 9 on as an afterthought. We do our subtraction, multiplying subtraction, and we get 5. So let's do negative 2 times g of negative 5. Well, that's the same as negative 2 times, now we go over to g of x, and we see it's negative, negative 5 squared plus 2 times negative 5, placing negative 5 in where x was over here. And then we will take and do our thing. So first thing is PEMDAS, we do parentheses. Well, inside the parentheses, I have an exponent, which is going to be positive 25, because the square is going to do negative 5 times negative 5, making it positive. And then I have a times, which is going to be negative 10. And now I still have to add these two together. So 25 minus 10, which is negative 15, or positive 15. So we have negative 2 times 15, which gives us negative 30. Okay, these are a bit complicated, but they're not undoable. You just have to take them one step at a time. Okay, so this one we have negative 13 is being made equal to the f of x. This one's backwards. This is not where we're trying to find y, we're trying to find x this time. So we have to take negative 13 and equal it to the equation and then solve for x. So we move the opposite of plus is negative, so we do minus 8 from both sides, getting us negative 21. Then we divide by negative 3, and that gives us x is 7. We can check that by seeing if we put 7 into the equation, 8 minus 3 times 7, do we end up with negative 13 as an answer? So here's our check. We're going to do 8 minus 3 times 7 is 21. 8 minus 21 is negative 13. And that is what we were needing, so that is a check. Okay. You can also put the equation into the calculator like I taught you before. Put the left side in, tab, put the right side in, and then find where they cross. Whenever we do that, we are looking for the x. So that this only happens when you're looking where the f of x is equal to a number, not when you're plugging in like we did up here. When this is called plugging in, this is called solving for x. Okay. So the last type of question is, let's say we had a graph and we are given f of negative 3. We would go to negative 3 and then go up to the y, and that would be the answer. So on this one, we go 1, 2, 3, 4, up to where the graph is, and that's at positive 2. Okay, I'm going to let you guys do the rest of those. Okay, so what are zeros? Zeros are solutions to functions. Graphically, they are the points at which the graph crosses or interacts with the x-axis. Algebraically, they're the point at which f of x is equal to 0. So whatever the equation is, it would be equal to 0. That's what algebraic is. And it's the x answers when you have done that work. We also call them roots. They're called x-intercepts, and they're called solutions. And of course, zeros. So we can do this graphically. So where on the graph does it cross the x-axis? So again, we're only looking at where it crosses the horizontal axis, that x-axis. So whenever you're looking for zeros, kind of highlight your x-axis mentally or physically and circle any place where it's crossing. And that is your solutions. And so those are all your solutions. So what is the x at this first one? It is at negative 2, and x is at positive 1. So there were 2. This time the x is at just positive 3, and this time it's at 1, 2, 3, 4. X is negative 4, and x is also at 1. So you guys do the last two. Okay, so doing it algebraically, all we do is set the function equal to 0 and then solve for x using SADMET, which is PEMDAS working backwards. So we're going to set it equal to 0. Then we're going to do the opposite of either subtracting or adding, which in this case is opposite of adding, which is subtracting. So that's negative 2 is equal to 2x. Then we do the opposite of multiplying or dividing, which is opposite of multiplying is dividing. So x is -1. Sometimes you should get the same number of a solution as your highest exponent. So x is 1, you should have one solution. When x is 2, like down here at number 13, you'll have 2 solutions or possibly 1 depending on what is happening with that graph. Now you can always, as a backup, graph your picture to see if you got the right x when you did your math. Okay, so we'll do number 10 as one more example because it has a fraction. Same rules apply. We set it equal to 0. Now we're doing opposite of adding or subtracting. I see subtracting, so I'm going to do the opposite, which is adding. And then I see multiplying, so I'm going to do the opposite, which is normally division. But since I have a fraction, I'm actually going to do the opposite of the fraction, which is flipping it over. It's kind of a trick for fractions, okay? Because the 2's cancels, the 3's cancels, leaving x. And then 2 goes into 6 3 times, so we really have 3 times 3 left over, which is 9. Okay, using the graphing calculator, you would graph it. So we're going to do a quick graphing. New document, don't save anything, go to graph, and we're going to type in everything after the equal sign. Notice it already says f of x on your screen. So we're going to do x squared minus 16, hit enter, and you can see where it's on the graph. But if you want to know for sure, push menu and then 6 for analyze, like we did before with the intersection, but this time we're looking for the 0. So we're going to pick 0. And then you just move your dotted line off of the 0, pull it across, and you'll see the first one pop up. So x is -4 is one of them. And again, it's just the x value that we're looking for. And then if you pull across enough, excuse me, the second one will pop up, and that is x is 4. So that is how you would do it graphically. Okay, so that works for all of them, and you can just put in the equation exactly how you see it after the equal sign, then push menu 6, 1. Menu 6, 1. Okay, and I'm going to write that on here as well. Menu 6, 1 for zeros. All right, so that is the end of this note.